Here we have 2006 relative velocity, two airplanes A and B moving horizontally, so they're horizontal to the ground, and they're traveling both at 200 kilometers an hour, and there's a wind blowing from the east, so it's coming in this direction, and the actual directions are northwest and northeast. So a little diagram here, maybe if we imagine plane B is going in this direction, all the angles here are going to be 45. So this is B, it's going in this direction. Plane A is going up in this direction, also at an angle of 45, northeast, southeast, all of these, that's A. And the wind is blowing in this direction here at 60 kilometers an hour. So 60 would be that speed. Speed of A is 200, or speed of both actually is 200. And we're asked for the speed of airplane A in still air. Okay, let's go the way to this. Let's have a look at the velocity of A. It is going to be in a negative positive direction, so minus 200 by the cos of 45 in the I direction, plus 200 sine 45 in the J direction. I might give these numbers. Minus 141.42 in the I direction, plus 141.42 in the J direction. We have the velocity of the wind, which is going to be in the I direction minus 60, in the I direction plus 0 in the J direction. And this speed of airplane A in still air is the velocity of the plane relative to the wind, which is velocity of A minus velocity of B, or minus velocity of W, what we're using here, which is going to give minus 141 minus 60, so it's going to give minus 81.42 in the I direction. In the I direction, and plus 141 minus 0, so just 141.42 in the J direction. And the magnitude of this will give me the speed. That will be the square root of 81.42 squared plus 141.42 squared. That's going to give 163.18, so 163.2 kilometers an hour. With the speed of airplane A in still air. Possibly could have taken this approach too. We have the speed of the wind 60, and we have the airplane is going to be traveling in that direction. This angle will be 45. This is 200 for the airplane, and we're looking for this speed. We could use the cosine rule because we have the two sides and the angle in between. That could be another approach that you could take here. You get the same answer. Part B of this question, or part 2, we got the magnitude and direction of the velocity of A relative to B. The velocity of A relative to B is the velocity of A minus the velocity of B. We have the velocity of A. What's the velocity of B? It's going in a plus direction. Again, they're going to be sines of 45, and the speeds are the same, so we can say it's definitely going to be 141.42 here for both. In the I direction, plus 141.42 in the J direction. And if I have the velocity of A minus the velocity of B, I'm going to end up with, I'm going to have minus 141.42 minus 141.42. So it's going to be minus double 141,282.84 in the I direction. And then I'm going to have 141.42 minus 141.42, so that will be plus or minus 0 in the J direction. So the magnitude of this velocity of A relative to the B, when we only have one component, is the square root of 282.84 to be squared, which you could probably just write as 282.84, but you know you're going to have to jot that down anyway, so maybe just write it down in kilometers an hour. And the direction, the inverse tan, well, there's no inverse tan here, the direction is just minus I direction, so that's going that direction. No need for the inverse tan, it's just due west, it's going west. It's like driving to Galway, due west is the direction and the magnitude we have. So that's the end of this question.